Okay, find the absolute min. One thing about finding the absolute min that some people have started to notice as we've practiced problems where they ask you to find the absolute min is it does take some practice on different types of problems before you start to feel more comfortable with the overall strategy. What the AP graders often do is they think of this as a candidate's test, or they refer to finding the absolute min or the absolute max as a candidate's test. Therefore, they give points for the student identifying candidates as the first step. It's easy to get this first point, the point for identifying the candidates. That's what I've tried to outline here, that the max of F always occurs at a critical or end point of F. Let's move that box over. Critical or end point of F. Gotta fix those now. Hold on. So we talked about this part before, that the max of F, come on, the max of F always occurs at a critical or end point of F. That's how we find the candidates. So we've got to pay attention to where F prime is either 0 or undefined. So I look over here, and I've noticed here, here, and here. So if I write on my paper, F prime of X is equal to 0 when X equals -2, that's this one, 2, that's this one, or 5, that's this one. I have now identified the candidates. And by identifying the candidates, they usually will give me a point for that. In this particular case, they did, so that was 1 point for getting there. Okay, the other two candidates, which I don't have to write down, so I'm going to put those over here off to the side, are the endpoints. X equal -6 and X equal 5. So there are 5 candidates in this problem. Now, what will happen is from problem to problem, what we do next varies depending on the problem situation, the different parts of the problem. There are different ways to proceed from this point. But basically what the grader is looking for on any absolute min or max problem is the grader is trying to, the grader wants to see that the student does something with each of the 5 candidates. In other words, we're trying to find the absolute min. Well, the absolute min is going to occur at one of these 5 locations, one of these 5 x coordinates. And in our work, we have to eliminate 4 of the 5 somehow. If we don't eliminate all 4, we will not get the justification point that is given in this problem. So to get the justification point, we have to eliminate 4 of the 5 candidates. There are 5 possible x coordinates where the absolute min can occur. We have to eliminate 4 of them. That's what the grader is looking for you to do. You can eliminate candidates using integrals, or you can eliminate candidates sometimes using increasing, decreasing statements. That's what this is for. So I have 2 options. I can eliminate candidates using integrals, or I can eliminate candidates using increasing, decreasing statements. It kind of depends on the problem which of those 2 methods is easiest. So, what do I want to do on this one? On this one, I've already found, if you look here, so I already found in part A, f of negative 6 and f of 5. So I've already found the endpoints. So I've already tested two of the candidates. I have already found the values of f here and here. I would need to test or eliminate the other three candidates, the candidates here. So as I'm thinking about what's the best approach, one thought is looking at x equal negative 2, I decide to write this. At x equal negative 2, f prime changes positive to negative. Therefore, f has a relative max at x equal negative 2. Well, f can't have its absolute min where f has a relative max. So this statement right here is sufficient as my elimination of this candidate. So I've tested, let's write these down. I know the value of f of negative 6. Found that earlier. That was in part A. That turned out to be f of negative 6 turned out to be 3. So let's write that down. Oops, positive 3. So f of negative 6 turned out to be positive 3. F of 5 turned out to be 10 subtract 2 pi. Well, 2 pi is about 6.28. So that's 10 subtract about 6.28. So that's somewhere in the vicinity of 4. Certainly bigger than 3. So at this moment, the lowest value on f is y equal 3. So far, this is the lowest value on f because this value is just slightly higher. I've eliminated x equal negative 2. That can't be the lowest because that's a relative max. X equal 5, that's an endpoint. I've already checked that as well. So I really only have 4 candidates. My 4 candidates are, notice how I keep writing. This is how you keep yourself moving on the AP test. Don't sit and think, just keep writing. So the candidates really are x equal negative 6. Already checked that. X equal negative 2. I've eliminated that candidate. So I checked this one, I've eliminated that one. X equal 2, I still need to do something there. And I've checked x equal 5. And I've eliminated that because the y-coordinate on f at x equal negative 6 is actually lower than the y-coordinate of f when x is equal to 5. So one last place to check, which is right here. So let's do that. So I have to use the fundamental theorem to do that one. So I'm going to integrate color. So I'm going to integrate from negative 2 to 2. Negative 2 to 2, f prime. And that's going to equal f of 2 subtract f of negative 2. Therefore, f of 2, rearranging, must equal f of negative 2 plus the integral from negative 2 to 2 of f prime. Again, this is a good example of why I don't really like doing absolute max problems. Getting the first candidates here is usually pretty fast, and I can get a point there. It's the justification that always seems to take too long. So So I don't like to do, I'll get the candidate and then often we'll go do other things before I finish this problem. But anyway, running out of space here. So that means, let's rewrite this, let's copy this over. Okay, let's go, okay, so right here, I'm going to get f of 2 will equal f of negative 2, which is 7, plus the integral from negative 2 to 2 of f prime. So that means f of 2 is going to equal 7 plus this integral from x equal negative 2 to x equal 2 is completely negative. It's a half circle, so that's pi times the radius squared divided by 2. I do have to do a little more work on this, so I get 7 minus, I found the minimum. This is 2 pi, which is definitely 7 minus 6 is very close. 7 minus close to 6 is close to 1. So this is the absolute minimum value. So I need to write a conclusion, so I say, therefore, the absolute min of f is f of 2, which is equal to 7 minus 2 pi. They only gave one more point for that. So this particular absolute min-max problem was only worth 2 points. The candidate got you one of those points. That's why I say for an absolute min or max, I would find the candidate first, the candidates, because that goes really fast. And then, depending on the problem, I might just move forward, come back later trying to find and justify my answer. Sometimes I get 1 point for justifying, 1 point for the answer. In this case, they give 1 point total for justifying and finding the answer. So part C was only worth 2 points.